Next problem up, we're looking at a line 1, 2, 3, 4, 1, 2, 3, 4. And x equal y minus 2 squared, so shift it up 2 units. 1, 1, 2, 1, 2, 3. Okay, so we're looking at this region. Remember, we're going to pick our rectangle parallel to the axis of rotation. So I need to figure out, in terms of y that's given, that is x equal y squared minus 4y plus 4, and in terms of y, x equal 4 minus y. My 4 look like, there we go. Now I need to figure out where those intersect, so I would take x, which is 4 minus y, and set it equal to y squared minus 4y plus 4. Minus 3y, so I'll get so volume is going to be the integral from 0 to 3, and this is in terms of y, and I'm going to take 2 pi times the radius. I'm going to run from the x-axis, and if along the y, I'm going to call that y, that's the radius, and the height. The height is really right minus left. Right would be the line. The line is really 4 minus y minus the left. Now let me move this. And let me move this a bit to the left. Minus, again, make sure to use parentheses. The left is really y squared minus 4y plus 4. You integrate that, and that would be your answer. Now, let's spice this up just a bit. So now we're no longer gonna move it along the, rotate it about the x or the y. We're gonna shift that slightly. So just like we did with the washer method, we're going to take top minus left, top minus bottom, and left minus right. Use cylindrical shells to find the volume generated by revolving the region bounded by the given curves about the given axis. X equals 3 minus y. Well, that's the same as the one we just did. 1, 2, 3. And 1, 2, 3. There we go. That region. X equals 0 and y equals 0. X equals 0, y equals 0. So they're talking about this region. We're going to revolve this about the line x equal negative 1. If we revolve it about the line x equal negative 1, then this is going to create an identical copy right there. Oh, I got it backwards, fully backwards. Oh boy, this is embarrassing. That's what I meant to write. So, when I go in and I pick my rectangle, it's going to be always with the original graph. It's going to be in the original graph, parallel to the axis of rotation. This is going to create an identical copy right there. And there's the cylinder. You could always see the cylinder in front of you. And volume is going to be the integral. And I picked it in terms of y, x, so that's dx. From x equals 0 to x equal 3. You could tell from 0 all the way to 3. It's going to be 2 pi, the radius. Let's get that out of the way. I go from the x-axis, from the origin, always the origin, to wherever it shows that, call that x. Isn't the radius really this distance? So right minus left. If this is x, right, which is x, minus left, minus a -1 is x plus 1. That's the radius. And as for the height, top minus bottom, the top is 3 minus x, the bottom is 0. There it is. So that's what's so complicated about this section. How about here? X equal cube root of, so cube root looks like this. Y equal x over 2, so 0, 0, rise 1, run 2. Okay, I get it. So 0, 0, when x equal 1, y equal 1, right? So the graph runs this way. And y equal x over 2, 0, 0, rise 1, run 2. The line runs this way. And those two cross somewhere. This graph is not to scale. Oh, except there's an issue. Okay, I fixed the issue because this line continues and you end up getting 2 of those. So in quadrant 1, now we got it fixed up. So the region we're talking about is really right there. We're going to rotate this above the line x equal 4. 1, 2, 3, so 4. Let's see where those intersect. Where does cube root of x equal x over 2? Remember the graph looked like this. So you get the 0, the positive, the negative. So radical 8. Radical 8 is a number before 4, which is good. Right? Radical minus 3. So it's a number less than 3 even. So the graph is way off. Let's say that's 1, 2, 3. Radical 8 is about right there. So that's really kind of how the line looked like. So I know how this works. I'm going to rotate this above the line x equal 4. Well, that's going to create an identical copy, just like that. And the reason I don't care much about the copy, because it's not part of the problem. It's only for visual uses. And if I pick my rectangle parallel to the axis of rotation, there's my cylinder. Now, volume is going to be the interval. I'm doing this with respect to x, from x equals 0 to x equal radical 8. 2 pi, the radius. I'm going to go from the x-axis, from the origin, and call this x. Now, isn't this the radius in reality? Right there? Right minus left. 4 minus x is the radius. Times the height. The height is the top, which is the cube root of x, minus the bottom, which is x over 2. And that pretty much defines the volume for us. Right there. How about this? X equal y squared. So y squared 0, 0, 1, 1 looks something like that, looks like this. And x equal 2, rise 1, rise, no, 1/2. So it looks like this. Oh, the color didn't change. Wider, right? So how does that work? Well, the region is right there. Where does y squared equal y squared over 2 plus 2? That is when 2y squared equal y squared plus 4, y squared equal 4y equal plus or minus 2. Right, I can figure out what x is, plug that in. X would be at 4. So they cross at x equal 4. Okay, well, let's see how this works. About the line y equal negative 2. About the line y equal negative 2. If I rotate this, wouldn't that create an identical copy just like it right there? And that will create an identical copy like that. Something like this. In which if I pick my rectangles parallel to the axis of rotation, there's my cylinder. It's a sideways cylinder. Volume would be the integral from y equal, we said, negative 2 to 2 of 2 pi. The radius, I'm going to run from the origin, wherever the origin is, and wherever you chose that to be, and call that y. Now, isn't this the radius? Top minus bottom, y minus a negative 2 is y plus 2. That's the radius. The height. The height is right minus left. Right is y squared over 2 plus 2 minus left is y squared dy. And that would be my volume. There you go. How about this? Y equal x squared. Well, that's a nice graph. We know how that looks like. 0, 0, 1, 1, 2, 4. So x equal 1, x equal 2. Okay, I see how it is. I'm going to shift that a bit down. There. So, y equal x squared from x equal 1 to x equal 2. Let's say that's 4. Right? And I should say y equals 0. Now it's set. Okay, and how does that work? So now we're talking about this region. And I'm going to rotate that about the line x equal negative 1. So wouldn't that create 1, 2, 1, 2? Wouldn't that create an image right there? In which the line x equal negative 1 would be the center of those 2 units, 2 units. You pick a rectangle parallel to the axis of rotation. The cylinder is right there. So, volume is going to be the integral from x equal 1 to x equal 2, 2 pi, the radius. The radius, I'm going to run from the x, from the origin, and call that an x. Isn't the radius this distance? That is right minus left. And the height of this rectangle is top minus bottom. Top is x squared minus 0. If you want, you don't have to put that, of course, dx. That will generate the volume for me, and that's what it is. And if I look at my last example, I have a hyperbola 1 in each direction. So, oops, missed it by a mile. There we go. The graph looks like except x equal 2 we're talking about this region. So none of this rest of the stuff matters. And where does, if I put a 2 right there, I'll get 4 minus y squared equal 1, 3 equal y squared, y equal plus or minus radical 3. About y equal 2. If it's about y equal 2, I want to shift this whole graph down a bit. And there's good. Y equal 2 is this line. It's not fully centered. Here. Let's center it right there. Perfect. Okay. Y equal 2, because cube root of 3 is about 1 point some. So y equal 2 is above that. There's no overlap in this class. So this is going to create an identical copy, something like this. Now, I'm going to pick my rectangle parallel to the axis of rotation. There it is. Volume is going to be the integral of 2 pi from negative radical 3 to positive radical 3 with respect to y. The radius, I'm going to run from the x-axis, from the origin, and call that x. And isn't the radius that distance, which is this distance? Top minus bottom, 2 minus x. The height of this is right minus left. The right is the line 2, and the left is the equation. What's the equation? The equation, if I'm doing this in terms of x, that will be x squared minus y squared equal 1. Swap, move that over, x squared equal 1 plus y squared, and x would be plus or minus the square root of 1 plus y squared. The negative we take out because that's this, so it's x equal the square root of 1 plus y squared, and here I messed up. When I went up on the y-axis, that's y. There you go. And there it is. Let me just make sure. X equal 2 minus, yeah, that's right. Okay, that would be it.